Okay, so today, just start recording, Hamza.
Sir, recording started.
Okay, thank you so much. Okay, Bacho, today we are moving towards our new chapter. The name of this chapter is the rate of reaction. The name of this chapter is the rate of. Okay, thank you so much. And you can say that it is speed of reaction. Okay, these are the names of this chapter: rate of reaction and speed of reaction. Okay, and it is a very short chapter, but it is very important and very interesting chapter, right? So you need to keep in your mind all the things that I'm going to tell you, and it will help you out to solve any question related to this chapter. Okay, then we are moving towards few apparatuses first, then we'll talk about these things later on. Actually, what is rate and what is the speed? It is actually, you can say that the formation of product. You can say that it is the formation of product, and you can say that, or you can say that it is a consumption of reactant. You can even say that it is a consumption of reactant, and you can say that it is a formation of product over time. This is the speed of reaction. Whenever we talk about the speed in chemistry, so it is just like that. Okay, it is always talk about the formation of product, and it is always talk about the consumption of reactant. So we can find out the speed of any reaction by these two methods, right? Even we can find out the speed of formation of products, or even we can find out the speed of consumptions of reactants, right? Now, for example, this is the very basic equation which is used in this chapter. You will see that this equation used multiple times in this chapter. Okay, so you need to remember this. It's a very important one. It is a solid, it is aqueous. We know that acids are aqueous, and it is a soluble salt, so it is aqueous, and carbon dioxide is gas, and it is liquid. So the very important thing is over here is solid calcium carbonate, right? And it is gaseous carbon dioxide. These two are very important thing to find out the rate of reaction. It makes is easier to find out the rate of reaction. Now, the first thing that you can use to find out the rate of reaction is the solid. You can find out like this. You can take a conical flask, right? You can attach a wool over here, right? You can use calcium carbonate over here. This is calcium carbonate, and you can add HCl over here, right? You can add HCl. This is HCl, right? It is aqueous HCl. It is what? It is calcium carbonate, right? And it is a cotton wool, right? And we can attach a machine of, you can say that it is a weighing machine. You can attach a weighing machine over here, and it is like that. Okay, and definitely on the weighing machine we have a screen as well, a very short screen on which we can check the mass over there, right? So it will be like this. It is written in this way over here. So this is the first method by which we can find out the rate of reaction. How can we find out the rate of reaction? It's very easy. We know that when we add calcium carbonate and HCl into the beaker, we will see this reaction. So we know that this is the gas. So gas start evaporating from here. It will find a space and will emit out from here, right? Hamza and Asna, right?
Yes, sir.
Yes.
So you can see over here, gas release, right? Gas release, the first thing you will see over here. So definitely when the gas release, so the mass deflects. It is also what? It is also decreases in the machine, right? So this is the decrement of mass in the machine. It is a decrement of mass in machine. So in this way, you can easily find out what the mass which is decreasing. You can easily find out the mass in this way. Just check the mass in first second, and you just plot it over here. Then the mass in second, you just plot it over here. It is continuously decreasing definitely, so you can plot easily the mass and with different points. And after a few minutes or seconds, the reaction is going to be constant because the mass is not further going to be decrease, because definitely the reaction is going to be and it will be like this, right? To you can say that we can manage it like this. I'm just going to manage for everything. It will be like this. वो straight हो जाएगा ना, वो straight हो जाएगा, so आपके पास क्या हो जाएगा, reaction आपके पास खत्म हो जाएगा. तो we can easily find this in this way, right? जब आपके पास ये जो ग्राफ है ये कांस्टेंट हो जाए, so it is showing us what the reaction ends. रिएक्शन क्या हो गया आपके पास, यहाँ पर रिएक्शन ends हो गया, और यहाँ पर जो आपके पास वैल्यू होगी वो क्या हो जाएगी, कांस्टेंट हो जाएगी, राइट बच्चों? और जो वैल्यू कांस्टेंट हो जाएगी, then you are able to understand the reaction is stopped now, right?
Yes.
Yes, Hamza, is that clear?
Yes, sir.
You can write these important points in your copy, quick. अच्छा, हमारे पास 5 बच्चे हैं वैसे मेरी क्लास में, और 3 बच्चे अभी नहीं हैं. We just have 2 students right now with us, so you can easily write everything, and if you want to ask anything, so you can also ask.
Are we going to do past paper practice in class?
Sorry, Asna, what are you saying?
Will we do past paper practice of the chapters in class?
Definitely, when I just completed this chapter, I will show you the past papers of this chapter after the class. Don't worry about that. Actually, Asna, when you completed this chapter now, so you will see that almost 70-80% past paper will be done by you as well, right? You will see in past paper the same graph over there, the same value over there, the same, everything will be the same over there, and inshallah it will help you out over there. Don't worry, okay? Don't worry about past papers. I am with you, and I definitely complete the chapter and will solve past papers as well. Now the second thing is, this is about mass, right? This is about mass of solid decreases. Now mass of solid decreases, so we can find out the rate of reaction by checking the reactant consumed. We are just actually finding out the rate of reaction by reactant consumed. This is the way that we can use the reactant mass, and the consumption of mass tell us the rate of reaction, right, boys and girls, right? Now we can check the production as well like this. For example, I just have a beaker, or you can say that I have a conical flask. I just connect this conical flask with a gas syringe, right? Right, this is the gas syringe. I just connected this with the gas syringe, and we know that gas syringe is graduated, so we have mark over here, right? So for example, if we have calcium carbonate over here, calcium carbonate, and just add HCl over there, so they start reacting, and when they react, definitely the gas will produce, and there is no way to pass the gas from here to, so definitely they enters in the delivery tube, start moving, and enter in the gas syringe, start collecting over there, right? Start collecting over there, and the plunger start moving backward. Okay, so in this way you can find out what you can find out the gas produced, you can find out the volume of gas, what we can found, you can find out the value of carbon dioxide after every second or after every minute. Whatever you need to find out, you can use whatever the scale you want to use over here. If you want to use the scale of time in minutes, you can use this, and if you want to use the scale in seconds, you can use this, right? Now for example, the volume of carbon dioxide is like is in this, whatever the 20 centimeter cube, for example it is, 30, 40, whatever the scale you can draw any. Most of the time in the papers they gave the scale, they gave you the scale, they gave you the readings, everything they will give you, and it is almost a 10 to 12 marks question in ATP, and many times they ask in paper 2 as well, and 2 or 1 MCQ will be in paper 1 as well. So for example, at 2, it will be 30, at 3, it will be 35, and then at 4, it will be 40, and then it will be constant, right? So you can see this, कि अगर आप reactant वाला graph देखोगे, so it will be like this. Okay, बच्चों? So volume वाला जो graph है, it is just like this, and the और जो आपके पास reactant वाला है, it is just like this, because mass is decreasing, right? Over here, mass is decreasing, and over here, volume of carbon dioxide increasing, right? Right, Hamza?
Yes, sir.
So this is the way that we can find out the, we can say that rate of reaction of the reactions. If we want to find out the rate of reaction of gases, and if we want to find out the rate of reaction of masses, we can use these two different ways, right? For gases, we can measure them. Okay, we can collect them in gas range, and whatever the apparatus in which we can collect them, we can use this for the rate of reactions. One more apparatus that I have to show you is just like this. For example, if we have a beaker or a conical flask, whatever that you are using for the reaction or container, you can use that. For example, we are going to have a reaction over there, and definitely gas is producing, right? So we can convert this into just like this apparatus. You can also convert this in this apparatus also, that in this apparatus we just use a gas jar in this way, and we can use these apparatus for the insoluble gases, the soluble that are insoluble in water, the gases that are insoluble in water, we can use this apparatus for that, right? You can use that. The gas liberates over there, definitely collect in this, and they start collecting over there, right? The insoluble gases. Okay. So we can even use this apparatus. We can use this apparatus for gases. This is the apparatus for gases, and this is the apparatus for gases, and this is the apparatus for mass, right? So we have these three apparatus that we can use to find out the rate of any reaction, and this is for mass, and these two are for gases, right? Right, Asna? Is that clear?
Yes.
And now one more thing, whenever the graph is going to be straight, you can find it out this. So at 4th second, reaction ends. So they can ask in exam that the time at which the reaction ends, so you can easily find it out in this way. Whenever the graph is going to be straight, it is going to be end reaction, okay? And over here, the reaction is ending over here, right? At 6th second, right? And over here, it is 4th second. Now we can find out the rate as well. We can find out the rate of reaction at any second. So you can see over here, at the first second, the volume is 20 centimeter cube. So if you want to find out the rate of reaction, so you can easily find it out, the volume of carbon dioxide and over time, right? So first second, you can see over here, 20 centimeter cube per second is the rate of reaction, right? Right?
Yes.
And in the second second, if you see that, the second second, if you see that the volume of gas is produced, it is only 10 centimeter cube that produced, okay? So the rate of reaction in second, you can see over there, it is 10/1. So it is 10 centimeter cube per second, right?
Yes.
And if you talk about the third second, it is just like this. It is almost 36. So the difference is 6 centimeter. So it is 6 centimeter cube per second. The rate number 3, right? And if you talk about the rate number 4, it is 4 centimeter cube per second, right? So what is observing over here? The observation is over here, you can see that the rate of reaction is actually decreasing with time, right?
Yes.
Why is that so? Hamza, can you please answer why the rate of reaction is decreasing with time? The speed of reaction is decreasing with time. Can you answer this?
Sir, because the amount of reactants are becoming less and the amount of the product is increasing.
Very good. Very well. The rate of reaction is depending on what? It is depending on the amount of reactants over there. When they combine together, they will form product, right? When reactants are going to be consumed, the rate of reaction is going to be lesser, right, Asna? Is that clear?
Yes.
Okay, that's very good. And now it's same over here. If you see over here, it is same for this graph as well. These two graphs are very, very, very important. Most of the time, they just ask question with these two graphs. All the time, almost 95% they use these two graphs, right? So you can see over here, and definitely it is something point over here, some point over here, point over here, point over here. We have different points. We can use this. The mass is decreasing now, so we can use, for example, we can use 50, 40, 30, 20, 10, right? So in the first second, you can say that definitely I just showed you the mass over here. We are checking this one now. So it is something 33, all right? So you can say that 50 minus 33 over 1. So the rate of reaction in the first second is 17 gram per second, right? That is consumed, right?
I don't understand that part.
Asna, it is about the decreasing. Now we are moving downwards. So initially we have what? Initially we have 50 grams, right? And when 1 second, I am talking about this part only. We are just talking about this part, okay? So you can see that on this part, this is the difference of mass, right? So 50 minus 30, whatever this, I am not confirmed that it is 33, but it is nearly, it is above 30 and it is less than 35. So I am just taking as 33. We don't have a scale right now over here, but we are just considering it is almost 33 or 32 or 31, right? Like this. So we are taking it 33, right? So when we minus 33 from 50, so we will have 17 gram that is decreased in this second, right?
Yes.
So it is 17 gram per second decrease the mass. Then if we talk about this second, so you can see that if we just follow this, so it is nearly 23 or 24 somewhere, right? So you can see that 33 and 24. If you take this, so it is 33 minus 24 over 1 second. It is almost, it is 6 and 3, 9 gram per second, right? And if you talk about this one, so it is almost 24 minus 20. So it is showing you 4 gram per second, right? And over here, it is less than 4, definitely it is 3 or 2, whatever. But the thing that I want to show you is what? The rate of reaction decreasing. The rate of reaction decreases, right? The rate of reaction decreases, right? But so you need to remember this. You need to draw these two graphs and these three diagrams. Just you need to sketch this, or you can take the snap of this. It is very important. And in the past papers, they all the time, I have told you that 95% they use these two graphs and these three examples, these three pictures, right? So you need to take the picture of this. You can take the picture of this, Asna, if you want to take, and Hamza, you can also take the picture of this. Okay, and in fact, we are recording the meeting as well, so you can review that lecture again, but still you can take the snap. So it will be very helpful after the class. Got it?
Yes.
Now, one more thing. For example, Bacho, and the question is with Asna. Okay, Asna, you need to answer this. For example, if I just use apparatus like this, I have conical flaws that I use all the time in all three apparatuses. I use the same example, calcium carbonate reacting with HCl, right? And definitely gas and the products are producing. And I just fitted, like this, or something which is like this. And I also use tap over here so I can collect this and close this, something that has what? That has mark over there. So this apparatus, Asma, can be used to find out the rate of reaction?
Yes,
use-
because
Okay.
it would vary.
It is what, Asna?
The reactance would vary because you're measuring from the ruler.
Okay, but what is going to be collect in this apparatus?
The product,
Which product? We have calcium carbonate. It is reacting with HCl, and it is forming calcium chloride. It is forming carbon dioxide, and it is forming water. So we have three products right now, and which product is going to be collected over there, and we can take it with the stopwatch to find out the rate. What can be collected over there?
carbon dioxide,
Oh, is that really? Carbon dioxide is not allowed to go from here outside.
water,
No, water will be over here. When they react, water will be here, salt will be here. We can only collect what? Carbon dioxide. But the system is not correct because it is not closed. If you want to collect any gas, if we want to collect any gas, we need to use closed container. So the apparatus that we use for the measurement can collect gas only. And definitely if the apparatus is open from somewhere, so definitely gas will release from there, because we know that gas diffuses from higher concentration to lower concentration always. So it will diffuse in air rather than in the apparatus, right?
yes,
Okay, so this point is for your remembrance. So you can easily remember that we can find out the rate of reaction by using what? We can use what? Electronic balance. You can say the word to it, electronic balance, or you can say it is a digital balance. You can use a digital balance or electronic balance to find out the rate of reaction, along with what? A stopwatch. Stopwatch is very important to find out the time, right? These two apparatus are very important for the rate of reaction for this apparatus, right? And definitely you can use a beaker, whatever you want to use, you can use over here, as conical flask is not fixed. Then over here, what we need to use? We need to use a bung over here, which close the apparatus, right? We need to use this delivery tube and gas syringe. So in paper, they most of the time use the word gas syringe along with what? Along with the stopwatch, okay? And definitely a bung which close the apparatus and conical flask and delivery tube, right? Right? These are the apparatus that we can use to find out the rate of reaction. Okay, Asna and Hamza, is that clear?
yes,
Okay, and then you can use this as well. But this apparatus is only used for what? The gases that are insoluble in water, because definitely the gas is going to be passed through the water. So if it is insoluble in water, that means it can collect over here. Otherwise, it will not collect, and we are not able to find out the rate of reaction. Okay, and in all the apparatus, on all these three apparatus, the main thing that we need to use is what? The main thing that we need to use is a stopwatch, right? Right.
yes,
And then you need to understand, whenever the gas is going to be formed, and you need to find out the rate of reaction by the formation of gas, then the graph is just like this. This graph is for the gas formation, the gas released during the formation, right, of products. And this graph is for what? This graph is for the consumption, or you can say that this graph is for what? The decrement in mass, right? Right? Mass, if the mass is decreasing, so you can use this graph, and if the gas is producing, then you can use this graph. It is very important. It will help you out in many MCQs. Okay. Here,
Yes.
so you need to write everything that I have told you over there. Everything that I have told you, you need to write, and you can take a snapshot of this as well if you want to take. You can take the snapshot of this.
I have a question.
Yes, you can ask any question, Asna.
Where are the recordings uploaded?
Nowhere.
Then how do I access the recordings?
You can send your email to me, and I will send on your email.
So can I get the recordings from before this chapter?
Before what?
Before this chapter, the rate of reaction, the chapters before this.
You don't need to. You don't need to use that recordings. I am here for you. You can learn all the chapters with me when I teach you. So that recorded lecture will be to you. Then can you hear me?
Yes.
Okay, I'm really sorry. There is an internet issue there. Okay, so I was telling you, Asna, you don't need to worry anything. We have a lot of classes together. I will teach you each and every topic. Don't need to worry. पहले आप मुझसे पढ़ लो. जब आप टॉपिक पढ़ लोगी ना मुझसे, फिर मेरी रिकॉर्डिंग जब आप देखोगी तो आपको आसानी होगी. और जब आपने एक चीज पढ़ी नहीं है ना, तो फिर उसकी रिकॉर्डिंग देखने का कोई फायदा नहीं है. पहले आप फिजिकली एक चीज समझ लो मेरे साथ, देन मैं आपको रिकॉर्डिंग भी भेजूंगा. डोंट नीड टू वरी. ओके.
Okay.
बट स्टिल अगर आपको चाहिए तो आप कह सकते हैं, मैं भेज भी दूंगा. ऐसा कोई इशू नहीं है कि मैं कोई रिकॉर्डिंग आपसे छुपाना चाह रहा हूँ. रिकॉर्डिंग आपके लिए हाजिर है. जब भी आपको चाहिए आप मांग सकते हैं, नो इशू। बट मैं आपको ये प्रेफर करूंगा कि अभी जो मैंने आपको चैप्टर पढ़ाया ना, पहले आप उसको रिकॉर्डिंग सुन लो, उसको देख लो, उसको प्रिपेयर कर लो, फिर उसको अच्छे से सॉल्व कर लो, बहुत अच्छे से, मतलब ऐसे सॉल्व कर लो कि उसको दोबारा जरूरत ना पड़े हमें देखने की। सही है?
Okay.
यस हमजा, इज दैट क्लियर?
Yes, sir.
ओके, सो वी आर जस्ट एंडिंग आवर क्लास ओवर हियर। और आप जो है मुझे रिकॉर्डिंग भेज देना हमजा, ठीक है? फिर मैं आपको भी भेज, बल्कि आपके पास तो होगी, मैं हसना को भी भेज दूंगा, ठीक है भाई? हसना, इज दैट क्लियर? जैसे ही मुझे
Yes.
हमजा रिकॉर्डिंग भेजेंगे मैं आपको भेज दूंगा, ठीक है? आप मुझे ईमेल एड्रेस अपना भेज देना।
Okay.
चलें, अपना ख्याल रखें, कल इंशाल्लाह मिलते हैं at 9 o'clock again and we are going to proceed this chapter towards the next level, okay?
Okay. Allah Hafiz.
Allah Hafiz, Allah Hafiz Hamza.
Allah Hafiz, sir.